You've been looking at different repeating patterns in nature, and hexagons are a fascinating pattern that appear all over the place. Regular hexagons are a six-sided shape in which all the angles are 120 degrees and all sides have the same length. An irregular hexagon has six sides, and all interior angles add up to 720 degrees just like in a regular hexagon. The even structure of honeycombs is an obvious example of regular hexagons in nature, but there are many more places where hexagons appear. Giant's Causeway in Northern Ireland, Devil's Postpile in California, and Svartifoss Waterfall in Iceland are just a few examples of hexagonal basalt columns. Insect eyes are actually made up of many tiny hexagons if you inspect one closely, and hexagons can even be found deep in the ocean in the structure of marine skeletons. Even snowflakes have a somewhat hexagonal structure with their six arms. So why do hexagons appear in all these places in nature on both a small and large scale? It turns out that hexagons are a very efficient shape. You can experiment with this by using bubbles. If you blow a bubble into the air, it will become elliptical due to surface tension forcing the bubble to have the least surface area and air pressure pushing outwards. Mathematically, a sphere is the most efficient shape because it can encase maximum volume while having the least surface area. If you force a bubble into a different shape, surface tension will always reform the bubble into a minimal surface shape. You can try this by making a bubble into different shapes like I am doing here. The bubble will always use the least material to cover an area, which is really fascinating. This means we can use bubbles to find the most efficient shape to cover a surface. So say you want to cover a surface with shapes of equal size so that there are no gaps. There are only three regular polygons that will work: squares, triangles, and hexagons. What shape will the bubble form? If you blow one bubble, you will see a circle. If you blow a second bubble equal in size right beside the first, the bubbles will have a flat intersection. When you make a third, the bubbles meet at angles of approximately 120 degrees. Now, if you add a fourth bubble, will an X-shaped intersection form? No! The bubbles rearrange themselves so that the intersections have 120-degree angles. Keep blowing bubbles of the same size, and hexagons will appear before you. This means that regular hexagons are the shape with the most area but least perimeter. Therefore, for bees, they would need less wax material than if they were to make square or triangle-shaped honeycombs. If bees use circles, then there would be excess space between the combs, and only 90% of the surface could be used for storage. Furthermore, hexagons with their angles of 120 degrees are extremely stable shapes for building with. What about the hexagon-shaped rocks? The approximately 40,000 hexagonal stones of Giant's Causeway and similar natural landscapes form from cooling lava. As the molten rock grows cold at different rates, it shrinks and the cracks form to release energy. By having hundreds of hexagons in a bug's eye, the most amount of light is let in, and there is the least cell wall. Try to find some other hexagons in nature and research the benefits of nature forming these amazing and artistic, yet mathematical structures.
Bingoa.